Hello, everyone. Today I have Paul Bates, Manager, Facility Safety and Workforce Development, Additive Manufacturing at UL. He is an industry recognized AM veteran. Bates joined UL in 2014, after serving 20 plus years at Reebok, where he guided the global athletic footwear leaders additive manufacturing lab and 3D CAD team as the Director of Advanced Process Engineering. A 2012 recipient of the Additive Manufacturing User Group Dinosaur Award, Bates is fluent in numerous AM processes, including DMLS, SLS, FDM, and PolyJet. Paul is a member of the SME for the past 16 years. He is the past president of the Additive Manufacturing Users Group, and he has a BS degree in design tech from Bowling Green State University and a master's degree in technology management from the University of Phoenix as well. Welcome, Paul.
Thank you very much. Hello, everyone. This is a very interesting and new format for me. I'm kind of excited, kind of weirded out. So let's get started and talk about additive manufacturing safety. That's what we're all here about, to talk about how to get safe with our additive manufacturing facility.
And can you share your screen as well, Paul?
I was sharing it. Oh, cool. How's that working for? Better? All right. So now we're sharing the screen. You get to see my great slide presentation. Who is UL? I guess it's a great question. Why are we involved in this? What is our stake in additive manufacturing? Well, as an organization, we're involved in a lot of things when it comes to safety for consumer products, for industry, for materials. Basically, UL is clearly the main focus is a lot on safety and material certifications and part certifications. Our goal is really look to how we can support additive manufacturing in a way that allows everyone to be the most successful they can be with that area of additive. What kind of way we can do this is certainly we do empower through trust. We have education and training opportunities. Someone asked earlier about additive manufacturer training. UL does provide some aspects of that. This presentation isn't on training, but certainly we can provide those services. There's also our certification capabilities we have, as well as marketing claim verifications. You name it, UL is involved in it. We would like to be able to support folks the best way that we can. But really why we're here today is safety. And my first question, and everybody can raise their hands if they want to, do I need to worry about safety? Is it as important at all? Could I just ignore it? Is it better to just close my eyes and hope everything works out okay? Well, I'll tell you, I probably wouldn't. The best way to look at it is you kind of have to worry about safety. OSHA's out there. They put out a clause years back that said you have to have a safe facility with the facility being safe. Your employees are not going to be exposed to hazards that can make them sick or dead. So kind of a rule we should be following. So what are the steps that we want to consider when setting up that safe and compliant AM facility? Well, one thing we have to look at is the technology itself. It's kind of unique, and it does pose some specific issues we need to worry about. And the process, it's not just the machinery itself, it's the process we follow to do this additive manufacturing process. The materials themselves can be dangerous, can cause us potential injury or health issues. The equipment itself certainly does. The operation of it, the folks operating the equipment can actually pose some risks. And then there's other unique hazards that can kind of mess with you as well as you're doing these types of operations. So what are the challenges to making a safe, compliant with facility? Because we've decided, right, as a group together, we're going to be safe. Well, what are the challenges to doing that? And the first one is that there isn't a lot of statutes and codes that exist today that apply specifically to additive and call additive out. There's no real standards of repute, meaning ones that we can count on for guiding us to make a fully safe facility. And in some cases, whatever standards we can find, there's some gray areas. They conflict with each other in some cases, where one's saying you need to have a certain safety protocol and the next one says you don't, because it's not targeted to additive specifically. There's really not a lot of industry best practices. Now, you can get industry best practices because probably you've created your own internally, but those best practices are not commonly shared amongst different organizations, different industries, and different competitive companies. And basically a general lack of awareness of what the safety requirements are and if there's a real need for safety. I was at a company not too long ago, and I'm sitting back and we were doing some training on a metals printing machine, and I was watching the process and watching the student go through the steps, and his manager leaned over to me and said, "Hey, do we really need to wear all that safety gear and practice safe procedures like this? It seems like a lot of stuff." And I said, yeah, you do, because you want that employee to be around for a while. And he kind of was a little sheepish about it. I'm like, if you're running a bandsaw, would you be concerned about its safety then? And yeah, because it's a bit more noticeable when it comes to safety, I guess. So how does UL and how should we approach these types of facility hazards? How do we understand them and recognize them? Well, we decided to split them in three ways. One is the materials itself, the second is the equipment, and the third is that actual encompassing area of that facility. So for materials, obviously there's a chemical concern of hazards. There's a chemical hazard. Deflagration, detonation, those are certainly things that can hurt you with some of the materials. Just the exposure to it can cause some issues. Some of it is flammable, and certainly overall your health can be challenged by some of the materials that we're using in additive, or some of the materials we use in a post-processing or secondary operations. For the equipment, it's electric. It runs on pretty good voltages. One of the pieces of equipment that I've trained on is 400 volts. Now, I don't know about you, but you grab a hold of those leads, that's going to hurt you. So there's some electrical energy to be worried about. And some of the equipment is pretty big. I was at a site where they do large components, almost the size of a house. You can imagine getting entrapped in a machine that size. Some of the energy, the way the energy is dispersed in the process, you can get exposed to that. Some have a non-ergonomic design, or the design's a bit challenging. Who here has used the glove box, right? And you get your arms through the gloves, and it's like your shoulders are getting crushed because they're just, is it me or the shoulder? They should be a little bit wider apart, those gloves. And of course, there's gases and under pressure that are involved in some of these pieces of equipment, and for various reasons, those can hurt you as well. And when it comes to the facility, the hazards in there is your emergency evacuation plan doesn't include the additive manufacturing component within your business. It doesn't seem like a big deal, but there's a difference there. And how do you understand the evacuation, particularly say for a gas leak of inert gases? Static electricity is a big thing when it comes to certainly in the powdered technologies and certainly in powdered metals. How are you managing static electricity? At explosive atmospheres, under the right conditions, you can create an explosive atmosphere. That's a bad thing. You want to skip that if you can and avoid those kind of atmospheres, and there's ways to do that. Inadequate SOP, standard operating procedures. Do you have a method to manage a powder spill? And is it documented? Is everybody aware of it? And are you following it? And finally, fire. If nothing else, if you're running a process that uses the materials that are flammable, what is your fire protocols? And do they meet the requirements for that material? And do they meet this local codes that are calling that out? So, quick question, are you sure these materials can hurt me? Can they really hurt me? And the question is, yeah, they can. And first we'll talk about metals, because we're talking about metals a lot in this venue. Usually comes in two forms, generally, powder and wire. The wire is not too much of an injury issue since it's in a solid form, but definitely the powder can be of a challenge. And under the powder, what are our risks? Fire and explosion, we talked about that. Exposure to it, if you get it on your skin or inhale it or ingest it, which is kind of scary, that can hurt you. If you're finding that you're eating metal powder on a regular basis, you should stop doing that because it's not something that's good for you. So when we talk about fire, if you guys haven't seen these images before, I recommend you look into this stuff, particularly if you're using any powdered materials. If you need to create a fire, there's a methodology for that. Basically, it's the fire triangle. Understand what it is and how it relates to your facility. To create a fire, you need air or oxygen, you need heat or some kind of ignition source, and you need fuel, which could be your powdered metal or other powdered materials. And what happens if you expand on that triangle and add a couple other vectors to it? And that would be adding in a dispersion component and a confinement component. And what happens then if you have those three, air, heat, and fuel combined, you can get into something beyond a fire, and that would be an explosion. So the risks are there. We need to understand that the risks are there, and we need to know that there are ways to mitigate those risks. So some scenarios where those things could happen, because you're like, yeah, dude, what's this explosive atmosphere? How could it possibly happen in my facility? We're using powdered materials, and again, especially powdered metals, in the powder storage room. It's a very common occurrence. Somebody drops a container of powder, for example, or they mishandle it. In the storage room, there's a risk there. Certainly in powder handling, when you load and unload powder from machines, a lot of this is done manually, and there's certainly a risk there. Some of the technologies do a much more automated powder handling process than others, but in the end, sooner or later, you're probably going to have to open up the machine and take powder out or put powder in. And finally, machine maintenance. One of the major areas we're seeing some of the challenges in this is when you're servicing your machine. You're exposing yourself to materials and risks because of that, the methodology of handling those materials and the risks that come with that. So real quick, dust and that other funny word, condensate. What are they? Well, dust is really how we can best define the powder we're working with. We talk about powdered materials, but when you get down to a certain size or certain composition under OSHA and the NFPA, they're really considered dust. And just understand that we're talking about some stuff that can aerosol pretty easily and be suspended in the air long enough to cause that explosive action. The other thing we have to consider too is condensate. That's that stuff that collects in the filtration systems in the machines, and it's that kind of vaporizer, that kind of sooty, smoky stuff that comes off during the process, and that stuff is really hazardous. It can definitely become an issue if you handle it incorrectly. It takes almost no energy to cause it to ignite or to explode. It's almost self-igniting, and self-igniting is a bad thing, so something to consider. Now, oftentimes I get asked the question, well, how do I if there was a fire, how do I put it out? I got a hose, I can just spray it with water, right? And the challenge there is it's not exactly the best solution. Look on your SDS sheets. Most of them will call out, in a metal powder, you can't use water to put those out. It's not recommended. They typically recommend a fire extinguisher suited for metal. So a Class D fire extinguisher. But on top of that, some materials react extra special with water added to them. They create an emission of a hydrogen gas under certain conditions, and that can really exacerbate and make the situation even worse. So you want to make sure you fight the fire, if there is one, the right way. If you're authorized to fight fires, be trained on it and understand how to do it. A Class D fire extinguisher is a very important thing to have on hand. So some of the basic hazards for powders. And I took this off of a couple different SDS sheets, so it certainly didn't make it up. And just know that there's a lot of issues. I know we're on short time with our presentation, so I won't go through all of these, but just know that if you're exposed to metal powders, it is unhealthy. It'll do things to your body. There's reproductive toxicities. That's a bad thing. Organ toxicity that can happen with certain materials. It is a carcinogen for in certain cases. This is bad stuff, so don't get it on you. And also it can affect the environment. So please don't pour it down a drain or shove it in a dumpster. This is hazardous material that needs to be disposed of properly. One question that I've had is actually a colleague got a phone call. And someone who was working metal powder said, hey, what do I do after I've inhaled a lot of metal powder? And boy, what a question. If you've inhaled a lot of metal powder, that's a bad thing. Don't. If you're not wearing a respirator, start to wear one. Wear one right away. Now, in current conditions today, getting a hold of respirators isn't easy, but when you're working in a facility, you should have those already provided by your employer, and you must wear those and wear those to be safe at all times when you're exposed to metal powder. Because once you inhale it, it goes deep into your lungs, down into the smallest component of your lungs. And guess what? It's going to stay there. There's no way to get it out. Once it's in there, it's going to reduce your lung capacity. It's going to create some potential scarring that can occur. And there's no medical treatment available, except after talking to a doctor. There is one way to solve this issue if you inhale a lot of metal powder. It's a lung transplant. Not recommended. If you can avoid it, I would avoid it. And wearing a respirator is the right way to avoid it. Now, if you're not comfortable wearing a respirator, you're not wearing the right one, that's something you need to resolve. You should have respirators in-house, and there should be a respirator policy so that you're fitted properly and wearing the appropriate respirator for the exposure you're going to expose to. So speaking of respirators, let's get into our personal protective equipment we need to wear. You need to wear it. And what does it do for us? It keeps us from being exposed to these nasty things, right? Whether it's powdered metals, it's emissions coming from a printer, whatever it might be, you need some sort of armor, in this case, or shielding to protect you from that exposure. And you must wear it. My favorite example is, and I'll demonstrate because we have a video here, but this is not the right way to wear safety glasses. I see it all the time. You do know that wearing safety glasses like this will not protect you. You have to put them, I guess, there you go, to protect you. So it must be worn to be protective and worn properly. So here's some examples of PPE, and this again is mostly powder-based, but these can be applied to certain other materials as well. But you need to have a respirator with a certain type of filter cartridge on it that's for the materials you're using. In Europe, it'd be, they recommend in some cases a P3 or a P100 here in the North America region. Safety glasses, don't worry too much about the standards. You know what safety glasses are with side protection. You should wear them. It's a good thing to wear in a shop at all times anyway. Clothes protective fire retardant clothing. This obviously is in the flammable materials area. You should wear that because being burned is really bad. You want to avoid that. Disposable protective gloves, certainly nitrile when they come into contact with certain chemical materials, or if you have a high heat situation, you want to wear high heat resistant gloves, and always wear safety shoes. Or picking up heavy things, maybe a build platform or some other equipment that's in the space, safety shoes are important. And if you're using powdered materials, particularly metals, ESD protective shoes are highly, highly important. Here's a great example of a best practice. I saw this demonstrated online, actually it was on Facebook the other day, the safe way to remove gloves. If you don't know how to do this, go and if you can find a thing on YouTube, I saw it'd be great. Or look at this imagery here. You want to pinch the glove off with the other gloved hand, and then slide your clean finger under the contaminated glove and peel them off and form a little package to dispose of. Again, anything on those gloves is a contaminated and hazardous material. When it comes to work clothing, I'm not going to read this whole slide to you, but basically what it's saying is you have to wear clothing to protect you for some materials, and if the clothing is contaminated with the material, whether it's powder, you need to dispose of the clothing. Taking it to washing it is not meant to wash off metal powder, because that's going to go in your laundry system, whether yours or a professional company you go to. But if you're laundering your protective clothing because it smells bad, you got lunch on it, whatever, certainly traditional laundering works for that. But in some cases, it can reduce the functionality of the protective garment. There's a certain lifespan of washings. It's a lot. I think for my jacket I wear is about 25 washings. So definitely that way. And if by chance, I love this one, if you do have a fire incident and you scorch the clothing, you should probably get a new jacket. It just kind of makes sense. And generally, if you're wearing a one-piece, two-piece, whatever you're wearing, as long as it's the appropriate protection for what you're exposed to, that's the critical part. So hazards of the equipment itself, this is just a quick introduction to it. Remember I said the machines have electricity in them and compressed gases. There's a bunch of other stuff that can hurt you. Hot surfaces are a big one. Sharp pinch points, things like that. Look for the little yellow stickers. They're all over the machine, and they were put on there by the sticker guy. And the sticker guy put a lot of effort putting those on. You should pay attention to those. They all have a certain amount of information on them. If you see a sticker that looks like a fire, like the little campfire one, it means that you can get burned. So be cautious with that. And the rest of them have their own purposes. Just know they're there for a reason and pay attention to them. So the facility itself, right? We have to manage the risks within the facility. And this is where things get interesting. There's inert gases used with some of these technologies, and they're a wonderful thing that we have to have in a process. It's going to really help the process itself, and it makes the process safer. If you imagine, remember that fire triangle, if you have a build chamber that's got a lot of metal powder in it, you're zapping it with some sort of energy source, like a laser or an electron beam, you've got 2 or 3 things. You've got your fuel and you got your ignition source. All you need is oxygen. So that's why the inert gases keep the oxygen out of the process. Really, really important. Secondarily is emergency escape. Make sure there is a methodology for getting out of the space if there's a problem. Fire certainly, and also an inert gas alarm. If you look in the picture in the right corner, there's a little box with a big red light above it. That is a oxygen sensor, and what that'll tell the people in the space is that the atmosphere is no longer safe to be in. The oxygen level is too low. Does anybody know what the right number is when we're in a good place for the amount of oxygen? Anybody? Hands up? No hands up, huh? I'll tell you. It's about 21%, right around there. You get below, you get into 19 or 18%, you're not going to start feeling good. You get lower than that, and bad things really start to happen. And this is not something that we make up or it's a that'll never happen to me scenario. It can happen, and it has happened. And not always just in the additive manufacturing space, but there's someone in the New England region who was at a medical center, and there was a nitrogen leak, and 2 people died simply because they weren't aware the atmosphere wasn't safe. So it's real important to understand that. Fire suppression, again, having the right fire suppression materials and system in place. And also there's always the chance that your facility doesn't have enough fire rating. Certainly be aware of that too. Improper ambient control. Certainly, you do know that humidity and temperature have an effect on how what the minimum ignition source or ignition energy that can create a reaction can happen. So keeping your heat and your humidity appropriate is important. Inadequate first aid measures, and again, remember, I keep mentioning static electricity. It's really important to understand that that issue can come in play. And some of the instances that I've seen happen or heard of happen in a facility have all ended up relating to, most of them have related to static electricity at some point. So one more thing, we're getting close to the end, but we want to talk about industrial hygiene. It's important to have a safe place, right? With clean conditions. OSHA does require this. You must maintain a safe and clean facility at all times, and that includes things like powdered material collecting. For 20 years, I ran or was responsible for a facility that used a lot of SLS or powder bed fusion polymer materials. It was basically powdered nylon, and we basically put in place multiple times a day of cleaning the floor because that powder just seems to go everywhere no matter what you do, and it makes it a slip hazard. And slip hazard is one thing, but you've got to maintain a safe environment for your workers at all time, including cleaning. One thing about our lab at my former employer at Reebok, it was always clean, always ready to go, because that was part of our process. So when we talk about powdered materials, though, there are some minimal or maximum areas that we can look at. I love the layered depth criteria. In other words, how much material can collect in a space. And according to some of the standards, you can have no more than a 32nd of an inch or 0.8 millimeters collecting on all your horizontal surfaces. So imagine how much of your horizontal surfaces there are. And to do a quick calculation, how much titanium powder would it take to cover everything with a 32nd inch of titanium powder? Then consider how much titanium powder costs. I don't know if I could explain to my management how I have that much collected on all my horizontal surfaces. If you have a lot of powder collecting, maybe similar to that picture on the screen there, that's a problem. It's an expensive problem, and it's a problem because you're not doing things right. There should not be an excessive amount of powder collecting everywhere, but there will be some. And you need to be able to keep up with that with your industrial or your hygiene within your facility. Clean, clean, clean. I mentioned before about moisture. Here's a little better example. It does raise all your minimum ignition temperature, energy, and composition. Those are things that are affected by that. So again, cleaning it is really important to maintain your safety in that space. So cleaning methods real quick. I know we're just about the end of this. Basically, this list of cleaning, basically I recommend the vacuum cleaning. That is the right way to clean up powder that's collected in your space. Sweeping and well, shoveling is always a challenge for me because if you get enough powder to shovel it, to clean it up, that's a big mess, and that's a lot of powder. Other than a massive powder spill by accident, I'm hoping that doesn't happen for you. Scoop and brush cleaning or wet water wash down, those aren't typical. Those are ones that are for more of a powdered material that isn't considered hazardous. But I would stick with the vacuum cleaning. Certainly a dampened towel using either an alcohol base or water-based cleaning. Just some kind of simple solution you can just clean and wipe and then dispose of it as waste. Wouldn't be a bad way to clean areas as well. But if you don't have a cleaning protocol in place, set one up, clean often. The one thing that my mom has always told me that you can never be too clean. So if your moms out there are telling you that as well, they mean in your additive manufacturing lab. So frequency on that, really just start out by doing it too much. You can always back it off, but don't wait until you've got that 32nd of an inch collected everywhere. That's a little too late in the game, I would believe. Just make sure that maybe every Friday or once a day or however you want to do it, but make sure you have a process in place and make sure you understand where it collects: walls, floors, overheads. Again, mostly the horizontal surfaces. Track those to keep up with that as best you can. And again, quickly, just waste disposal. There's a bunch of new procedures I've read about recently that have come out on this. Always work with your hazardous waste disposal company. They'll be following the state regulations on it because that's what they do. But just make sure that you properly contain that waste, whether it's from your wet separator or from your filters or whatever it might be, and seal up in the proper containers and make sure that it's disposed of the way that you need to dispose of it, and not just shove it in a corner and wait 6 months and maybe somebody will pick it up or not. Again, wet separator. Again, if you guys haven't serviced those before, service them. If you don't do it on a regular basis, start making that part of your plan. Not simply because it's a real hassle to clean if they sit too long, but in some cases, I know a lot of shops that clean theirs every day. And depending on which version of wet separator you have, some are easier than others, but just make sure it's on at a regular basis and dispose of that waste very, very carefully. All right, I try to hit 2 o'clock exactly. I'm pretty close. Again, if you need to reach out to me directly, certainly you can reach out to the email that's a generic one for UL, or you can just connect with me on LinkedIn, give me a call, however you want to get a hold of me. We can talk further about it.
Awesome. Thank you, Paul. And we do have a few questions on our Q&A. I think we can go for about 5 minutes or so. We want to.
Whatever you want.
Perfect. So number one question is, do AM equipment manufacturers work with UL on safety?
We've had definitely some good conversations with some of the equipment manufacturers. Some of them have actually really worked closely with us, so that we can understand better what protocols they have in place, and they can understand better what we have to offer. I think in a way they all are working with us because we do talk to pretty much all of them at one level or another. But I will say that the OEMs or the manufacturers of the printing equipment, for the most part, every single one that I've worked with or dealt with their equipment, they really do a good job on the safe use of their equipment, which is a component of a safe facility. They really do a great job. Their basic training always includes some level of safety training for their use of their equipment itself. When we talk about an additive facility safety, we go beyond that and look at all of the facility, not just that piece of equipment.
Awesome, thank you. Another question. Paul, can you speak to the challenges the industry faces in getting local, state, or national approvals for storage of powders? An example, titanium or aluminum.
Well, again, it goes back to understanding, where we are today in the industry. A lot of local and state organizations or the associated people that are responsible for that really don't understand what we're doing with additive right now. And I've had a great chance to meet with several fire marshals, state and local, to talk a bit about powder and safety and storage. And they've been really, really open to understand it, but where are they getting their information from and how are they learning about it? If they're trying to do it on their own, or if they're just becoming aware of it for the first time as they're inspecting a facility to sign off on occupancy, that's a challenge. I know that I've spoken at the NFPA, for example, in the past, and other areas, to talk to people that are responsible for it, to let them know that it's out there, and what some of the risks and challenges are, and trying to educate them. And education is what's going to get us there.
Awesome. Another question. With regards to equipment, most LPBF standards mention that vibration in the facility must be at a minimum. What vibration analysis can be performed, and what is an acceptable vibration reading?
Wow, I wish I had my vibration expert here, if there is such a thing, but I don't. When we look at a facility, we talk about minimizing vibration to the equipment just as much as anyone else does, and we do say that if there is a vibration issue, which, looking at other pieces of equipment in there, if they've been isolated, whether it's by a slab or by isolation feet or whatever on the machine, then you would want to obviously have that same type of a mitigation challenge there for the additive equipment as well. They are sensitive to vibration when it comes to some of the galvos and the ways that they steer the lasers and other things in those machines. But I don't know of a common denominator for that, certain number or specification or standard for that. But that just opens up the door to another example of how there isn't a standard in place at this point.
Awesome, thank you.
Another gap we have to fill.
Great. And we'll do one more question before we break for the networking session. Says, hi, Paul, this was very informative. I'm more nervous than ever to enter Metal AM facility now. How can you all help Metal AM service bureaus get it right in terms of safety and certification?
Well, first off, don't be afraid. It's like walking into a machine shop and everybody's in t-shirts and shorts, flip-flops, and no safety glasses. Yeah, you should be afraid, and you probably wouldn't call them a qualified vendor. If you walk into an additive facility and you again don't see recognized safety protocols in place, I'd be nervous too. But the challenges really are, when it was funny, somebody asked me, they gave a lot of tours, and they said, how can I make sure that my tours are safe? And I said, all you have to do is make sure there's no powder exposed. There's no powder containers open. You're not servicing the equipment. You're not doing a filter change. You're not depowdering something on a bench somewhere with somebody there. That's not going to be a big issue. It's really when, it's that exposure to the powder specifically is when the most risk is in place. But how can we assure that service bureaus and everybody else, really everybody needs to be safe in this, is really look at what kind of safety protocols you have in place, and are you meeting the requirements that we've helped identify. Certainly with you all, you can reach out to, look at our series of white papers we've put out on it, or certainly look at the standard UL 3400 3400. That gives a good look at facility safety requirements. But also, have you worked with the OEM of the equipment? And I don't just mean the 3D printer. It could be the depowdering station. If you have an automated depowdering station, what are the safety requirements for that? Have you been trained on it, and did you get the proper training? Make sure you have all those pieces in place, and you can set up a relatively safe facility. But if you have questions on it, point back to, certainly you can email me or give me a call. I'd love to talk to you about it more, about the steps you can put in place to be a safer facility.
Awesome. Well, thank you so much, Paul, for joining us today. We will now reconvene in our virtual networking session until 2:30. Thank you, Paul.
All right, thanks, guys.